Hello grade 12s, welcome to Learn Extra. Today we are dealing with mathematical literacy. The topic we're going to cover is the topic of measurement. Now measurement is really interesting because if we think about it, we need measurement for things to be fair. You don't want to go into the shop and say, I'll have a kilogram of flour, and the next day you go in and you say, I want a kilogram of flour, and the baker or the grocer gives you a different measure. You want to have a standard way of measuring. And in the same way, we measure things all the time. We measure the length of things, we measure the weight of things, or the mass of things. We measure time, we measure temperature, we measure all sorts of different things. And that's why the study of measurement is actually a science all on its own. But for our purposes, we're just going to deal with the very basics of measurement. So let's get going and see exactly what we're going to do today. We're going to, in this session, revise two very important systems. The first one is converting in the metric system. So we're going to talk about the metric system and how you do conversions of metric units. So when we're in the metric system, how do we convert one unit to another? Some things are very small, so we can't use a universal way of measuring things. We have to change the system of measurement depending on how big or small something is. Then we're going to look at conversions between metric units and non-metric units. Now there are a number of non-metric units. We're going to be looking at some non-metric units that are commonly used, as well as looking at the imperial measurement units. And so in different parts of the world, not everyone has converted to metric. I don't know why, because metric is so much easier, but for traditional reasons, in some parts of Europe and some parts of the United States, they use the imperial measures. And even then, they adjust things to suit themselves, and it becomes a huge discussion. In science, we have standardized those measurements to a large extent, but in common usage, most people still use what they've traditionally used. We're also going to look at some time calculations. Now, these can be extremely interesting and sometimes quite fascinating. And you kind of think, well, what exactly is going on here? But we'll get into that a little later. Let's start off with some explanation. So we're going to start off looking at the metric system. Metric basically comes from a French system where, because we count and we have our number system in units of 10, that's the decimal system. And everybody likes to multiply by 10. The metric system is generally and loosely based on powers of 10. So it's actually 1,000 or 100. So you can convert from one thing, either from 10 going up in units of 10. Let's just write it clearly. 10 or 100 or 1,000. And so we can step up in those sort of measurements. Each one of these smaller units has in fact got a name to it, and you should be familiar with it. So let's have a look at length and distance. If we're measuring length or distance, we could start with something that is in millimeters. So millimeters written as mm, and if we had 10 millimeters, we would get to the next unit. So the jump up to the next unit is to centimeters, and that is a jump of 10. It's a step of 10. We need 10 millimeters to get 1 centimeter. And then the next jump, so the jump there is a size of 10. The next jump to get from centimeters to meters is 100. Centi is like century. Century, from both the turn of the century and scoring a century in cricket, is 100. You should be aware of that. Century is not an unfamiliar word. So if we're going up to meters, the next step we'd get to is kilometers. And that step is 1,000. Now, I hope you can see that that's quite an easy way of going up in those steps. 10, then 100, then 1,000. So if you asked about conversions, my hint to you is you write this down on your exam paper or on the question paper, so you've got it very clearly. the important thing now that we've got to decide is if we're going from a small unit like millimeters to centimeters. So we're going from left to right on this table. What do we do? Do we divide or multiply? Well, you think about it. If I have 10 millimeters, that's 1 centimeter. So going from left to right, I'm actually going to divide. So if I'm going up the table, I'm going to divide. Centimeters to meters, I divide. So in that direction, going from small to big, I always divide. But if I'm going in the opposite direction, from kilometers to meters, I multiply. From meters to centimeters, I multiply. From centimeters to millimeters, I multiply. So from a very big unit, and you can think about it, a meter is about the length of your arm, a centimeter is about the length of your fingertip. The top of your thumb, and a millimeter is even smaller. It's as close as you can get to looking at it, and you've got your ruler. You look at your ruler and you'll see which one is the big one, which one's the small one. Recognize that when we're going from small to big, we divide. Going from a unit that is big to a smaller unit, we multiply. Okay, I hope you've got that very clearly and you understand about the change when we're dealing with length and distance. Now, what about mass? Well, good news, we have a very similar system. Instead of changing all the things, we've got milligrams, and then we have grams, and then we have kilograms. Now, the prefixes, these things in front, are the same in distance and in mass, and in fact in other units, if we chose to measure some other things, you would find they're the same. So you could get some things like milliseconds or kiloseconds. We don't often get those in everyday conversation, but it's possible that we could. Milli means 1,000th. Kilo means 1,000. So the difference between milligrams and grams, I want you to see the jump here in mass is not going up in 10 and 100, but it's 10 times 10, which is 1,000. And that makes it really interesting and makes it very consistent. From grams to kilograms, it's 1,000. So it's all based on that system of metric, units of 10. Now you'll see later that other units don't follow that rule. They don't follow a standard setup. Just to remind you again, if we were going from the small unit to the big unit, then we would divide. So milligrams to grams, you divide. Grams to kilograms, you divide. But if we were going from kilograms to grams, we'd multiply. That makes sense. 2 kilograms, 2,000 grams. 2 kilograms, it sounds small, but it's actually quite heavy. You know what 2 kilograms feels like? It's 2,000 grams. The grams is a smaller unit, so there are more of them. And if we were to go to milligrams, we'd multiply again by 1,000. Okay. Now, the next thing is volume. Now, there were 2 ways of measuring volume. It depends on what you're measuring. Usually if we're measuring liquids and we're measuring things that can pour and have capacity, that fill an object, that sort of measurement, we use the following system. We say we've got milliliters, and we've got liters, and we've got kiloliters. Now, see, it's very similar to the mass story. And again, you have got it right if you said, well, the difference, the jumps between these is 1,000. And the jump between that is 1,000. Absolutely right. And we'd follow the same rule. From the small unit to the big unit, you're going to divide. Going the other way, you're going to multiply. And that's all quite straightforward. Now, guys, what you need to recognize is that volume doesn't always get measured in liters or milliliters or kiloliters. We can also use a distance measurement to measure volume. And this is where it might become a little bit tricky. Because what we do is we can say, if we've got an object that is a square or a cube, then that has a certain volume to it. and you would agree that the volume, from what you've done previously, volume of something like this, they call that height and call that breadth. The volume is length times breadth times height. And so what would we say? If this was 1 centimeter, and that was 1 centimeter, and that was 1 centimeter, then we would get 1 centimeter times 1 centimeter times 1 centimeter. And that would give us something called 1 centimeter times centimeter times centimeter times centimeter. That's called a cube. Centimeter times centimeter times centimeter, cubic centimeters. And the interesting thing now is that 1 centimeter cubed is the same as 1 milliliter. Okay? So 1 centimeter cubed is the same as 1 milliliter. Very important for you to get to that. Now, if we had something that was 10 centimeters by 10 centimeters, so it's 10 centimeters by 10 centimeters by 10 centimeters. Notice 10 times 10 times 10, that's 1,000 centimeters cubed. And 1,000 centimeters cubed is exactly the same as 1 liter. And then we could even go to something that is 100 centimeters by 100 centimeters by 100 centimeters. And let me just draw it in because I'm now not being very clear about where those hundreds are. There's my box, 100 by 100. Let me just move that 100 there to where the box should be, or move the box so that it's very clear. So there it looks like that's better. So we've got 100 by 100, and let's just move that one to that position there. We've got length times breadth, and we've got 100 times 100 times 100. Now that is going to give me something that is going to be 100 times 100 times 100. That is going to be very big. It's going to be 1 million centimeters cubed. 1 million centimeters cubed. Okay? But now, what I hope you can see, that 1 million is actually, this is 1, 2, 3, this is 1,000 jumps. So it's 1,000 times bigger. There's 3, and there's 3, 0, so it's an increase of 1,000. But now, I've done that as 1 million centimeters cubed. But you're going to stop and say to me, but hold on, John. You've just told us earlier that you could have rewritten this 100 as not in centimeters, but 1 meter. So 1 meter and 1 meter. And if we've got 1 meter times 1 meter, what have we got? 1 meter cubed. And 1 meter cubed is the same as 1 million centimeters cubed. And guess what? Because it's 1,000 times bigger than a liter, it's also the same as a kiloliter. So there's the volume story. We're going to do some more on that, but make sure that you understand, if you're doing conversions of volume, go back and draw a little diagram. I find it the easiest way to do my conversions with volume. Okay, we've dealt with the important ones: mass, volume, and length. Those are the fundamental ones. There are some more that we'll come to. These are not necessarily metric. They don't go up in units of 100 or 10 or 1,000. The first one of these non-metric units systems is the system of temperature. Now, you might say to me, well, what units, how do we measure temperature? Temperature, you use a thermometer and you stick it into something. You say, oh, the temperature today is 25 degrees, or my body temperature is 36 degrees. You've measured temperature using a thermometer. Now, there are two systems. There's the system that we use, Celsius, and we measure it in degrees Celsius. The interesting thing about Celsius is it's taken for 2 points, and it's almost metric. 0 degrees Celsius is based on the melting point of water. So it's the temperature of ice when it's starting to melt. And the other point is 100 degrees Celsius, and they've chosen that to be the boiling point of water. And so they said, between these two, let's make there be 100 units. So it seemed to work. The trouble is, you can go as far as you like, you can't really change from milli-degrees Celsius. No, there's no such thing. It's one thing. There is a lowest point for the measurement of temperature, and that will be very, very cold. We won't get there. It will be minus 270 odd, somewhere around about there. You can't get lower than that. You can get as high as you like. The temperature on the sun is huge, okay? But it doesn't change, so it's not part of the metric system. This is the one that we use. We say our average room temperature on a normal sort of day, room temperature is 25 degrees Celsius. That's when it's comfortable. If it gets below 0 degrees Celsius, it's really quite cold. We need to put on a jersey and a jacket and make sure that we've got gloves on, perhaps even a scarf, put on some warm clothes and make sure that we're fine. Fortunately, it doesn't happen too often in South Africa. Now, what's the other measurement of temperature? And you'll see here, there's something called degrees Fahrenheit. Now, this is a unit of temperature that doesn't even use any sort of metric analysis at all. It starts at an odd place and it ends at an odd place, and it's taken water as its reference as well, but it just chooses an arbitrary place of 32. Why it chose 32, I don't really know. I don't think anyone really knows why that's kind of taken as a fixed point. But it is 32 on the Fahrenheit scale, and they decided that we'll make things 32. We'll go from there. They'll choose a different number, so the size of the units are different as well. So if we go up 5 degrees in Fahrenheit, it's not the same as 5 degrees in Celsius. So it's quite strange. Unfortunately for us, we need to know about this, because in other parts of the world, they think Fahrenheit is the great way to measure. So if you're listening to an international news bulletin and you're going on an overseas trip, you need to make sure that if you hear the weather forecast for somewhere is going to be 32 degrees, and you think, wow, I'll pack my Speedo and my towel and I'm going off to the beach, and you arrive there and it's snowing. Not a good idea. So you've got to know about degrees Fahrenheit. You've got to make sure that you understand the difference between degrees Celsius and Fahrenheit. Okay, we're going to use these formula. The nice thing about these formula is that they're always given. So if you want to convert something to degrees Fahrenheit, what you've got to do is you've got to take the Celsius temperature, you multiply it by 1,8, and then you add 32 degrees. That will give you your Fahrenheit temperature. If you want your Celsius temperature, you're given a Fahrenheit temperature, you subtract 32, and then you divide by 1,8. Right, let's move on. Another non-metric system is the system of time. Now, we use time all the time. Sorry for the pun. And you should be really familiar with it. But you'll see that it's not based on changing things in units of 10. It doesn't go up like a decimal system. It's very non-metric. It's non-decimal. And here are just some ideas that we've got. 1 year is 12 months, and there are 52 weeks in a year. We also know that most years are 365 days. But there's that thing called a leap year. A leap year happens every 4 years, and then there are 366 days in a leap year. Now, it happens every 4 years. The reason for this is that the Earth doesn't rotate or revolve around the sun exactly. So one revolution around the sun doesn't take exactly 365 days. It takes 365 and a quarter days. So every 4 years, we add a day so we can catch up. We can catch up with the position and make sure that we're in this right position. Otherwise, the seasons would go out and suddenly we would have summer in June, and we don't want that. We want to make sure that our months and seasons stay the same. So that's part of the counting story. Just to be aware that if you want to know if something's a leap year, then you take the year, like let's take 2016, and we take a look at 2016, and we say to ourselves, is it divisible by 4? Well, you know that you only really need to look at the last 2 digits over here, and you can say 20 is divisible by 4, that goes 5 times. These last 2 over here, they're divisible by 4 because 16 is divisible by 4. So, for example, 2013, 2014, 2015 won't be leap years. 2012 was a leap year. 2016 will be a leap year. Right. When we talk about weeks, we recognize that 1 week is 7 days. Some of you are thinking, I wish it was a nice round number and we'd had more of weekend. No, a week is 7 days, and that's been set for a long time. A day is 24 hours. Now, that's also quite strange. Why should it be 24 hours? Well, they just divided it into even amounts. And at the time, it seemed a good idea. There have been, by the way, movements long ago in France when they were trying to introduce the metric system to standardize and make time metric as well. And they allocated 10 hours to fill a metric day. And it didn't really work very well. People weren't comfortable with it, and they got so used to morning, dividing the day into half, so you have before noon and afternoon, depending on how the sun works. All of those things played a role in it not working. But maybe in the future we'll go into metric time, I'm not sure. 1 hour, 60 minutes, and 1 minute, 60 seconds. Now you can see the jumps then are 60, 60, 24, and 7. They're very uneven, not nice and pretty like the metric system. But we've got to get used to these. We've got to be able to convert them. We've got to be able to measure them. Now, there are 2 things that I just want to say before we move on. There are 2 ways of representing time. You might have an old-fashioned analog clock that measures something like that, but you could also have a digital clock that could say something like that. You need to make sure that you follow both if this was 4 p.m., be able to convert between those 2. This one is going up in units of 10. It's gone past the 12, so it would actually be 2 p.m. Remember, p.m. means post-meridian, after noon. p.m. means afternoon, a.m. means morning. So be very clear that you can do those sort of calculations. We've also got some calculations coming up in the example when we talk about the fact that the clocks are different in different parts of the world. Now, you don't have to know the calculation of those, that's more a geography skill, but you could be asked to compare clocks in different parts of the world and what's the time difference, work that sort of thing out. Now, let's move on to imperial measurement systems. Now, the one thing about imperial measurements is you don't need to know the jumps, and you don't need to really know the conversions. You will be given those conversions. But just as a matter of interest, if we take a look that there is a jump between inches and feet, 1 foot, there is 12 inches to 1 foot, there are 3 feet to 1 yard, and I think that there were 1,000 yards to 1 mile. Can't remember that exactly. You will never be asked those jumps, but you can see they're all different. The purpose of this is just to show you that they're different. In the same way, there are different jumps between ounces, pounds, stones, and ton. We don't need to know those. What we're interested in is being able to convert from an imperial measurement to a metric measurement. Now, how do we do that? Make sure that you understand the idea of ratio. So I want to just do one little example here. Say if I know that 1 inch is 25,4 millimeters, I want to know what 1 millimeter is in inches. So I want to know what 1 millimeter is. So how am I going to work out how many inches that is? See how I've set it up? I want to go from, I know that 1 inch is 25. I want to know what 1 millimeter is. I want to work backwards. So I'm going to need to use my calculator. And the steps that I'm going to go through is I'm going to say to myself, starting from this one, what did I do to get 1? I always like to get 1. And how do we do it? We don't add, we don't subtract. We either multiply or divide. And if I'm going from 25,4 to 1, what did I do to the 25,4 to get 1? I must have divided by 25,4. So I divided by 25,4 to get 1. So that means that if I want to take the 1, I must divide by the 1 by 25,4. I must do what I do to the one side of the ratio, I must do to the other. I must divide by 25,4. So let me just do that on the calculator so that you can see. I'm going to say 1 inch divided by 25,4 gives me how many millimeters there are, how many inches there are in 1 millimeter. And you can see that it's a very, very small number, 0,039. And I'm going to do it to 3 decimal places because that makes sense for me, 0,039. If I was rounding that off to 2 decimal places, what would I do? Well, I'd look at the third place, say, is it bigger than 5? Yes, it's bigger than 5. So I could round it off to 2 decimal places and say it's 0,04 inches. That means it's 4,000ths of an inch. 4,000ths of an inch, very, very small. That's 1 millimeter. Now you can see an inch is about the size of your thumb, the nail of your thumb, the part of your thumb, and we're recognizing that this is 4,000ths. We divided it up into very small bits. We've got the calculation right. Now you can do all these calculations in the same way. Just always remember, we're asking about the ratio. In the same way, we can do the conversions of mass. Ounces to pounds, pounds to stones, stone to ton, and we've got the metric measurement. And you can see this is about half a kilogram. An ounce is about 30 grams. A stone is just more than 6 kilograms. And a ton, this word ton with a double N-E, is the metric ton. It's 1,000 kilograms. So they're quite close. One imperial ton measured in the UK is this amount of tons, or 1,160, or was it, just hold on, let's go right there, 1,016 kilograms. 1,016, sorry, 16 kilograms. So we've just multiplied by 1,000 to get my ton into kilograms. Bear in mind with that. Okay, guys, you know what? I think we've done well in just summarizing these ideas about measurement. Let's take a short break. After the break, we'll be back to do some examples. So stay on your books open. Make sure you follow me. Get your calculators ready. We're ready to do some work. For now, take a stretch. We're going for a break. Welcome back, grade 12s. We're into doing measurement calculations today. Mathematical literacy, very practical stuff. Hope you're enjoying it. Let's get into some example questions now that you might find in a test or in a final exam. Now, you do need to be able to do all sorts of calculations of conversions, and we're going to just highlight a few examples as we go through them. So let's start with the very easy ones first. typical type of paper 1 question. So let's have a look at it. You're given the following quantities and you're asked to make some conversions. Now the first one, 35 centimeters, and you need to convert it to meters. Well, you should remember what we said earlier, that we're going to go millimeters, centimeters, meters, and kilometers. And we're going to write 10, then 100, then 1,000. And we're going to use that here. So we want to go from centimeters to meters. We know that we're going from a small unit to a big unit. You know that 35 centimeters is just a little bit bigger than your ruler, so it must be a fraction of a meter. So what's the way that we're going to do it? Take a look. The jump is 1,000, so we must take 35 and we must divide 35 by 100, and that equals 0.35. You can do it in your head or you can do it on a calculator. Check it on the calculator by all means and make sure that you've got the right answer. So the next one, we're looking at from 3.75 kilograms to grams. So remember that when we looked at grams and kilograms, we said you have milligrams, grams, and kilograms, and the jumps here going that way and going that way were all 1,000. And it makes sense that it's 1,000. So now we're going to go from kilograms, the bigger unit, to the smaller unit. What are we going to do? Yeah, you got it. We're going to multiply by 1,000. So we're going to say 3.75 multiplied not just by 10, not by 100, but by 1,000. So now if you do that, you'll find that this is 3,750. That's easy to see. It's got to be 3,000. Can't just be 75. Must be 750. Okay? 3,750. 3,750. Don't forget the units. What are the units we wanted? Grams. Make sure you've got them in the right units. Don't forget your unit with this sort of calculation. Next one. 2.75 liters, and we want to change it to milliliters. Remember, milli to liters, it's a change of, it's just like grams, milliliters to liters is the same. It's 1,000 jump, and we're going from liters to milliliters. So what are we going to do? We're going to multiply by 1,000. So 2.75 multiplied by 1,000 is equal to 2,750 what units? Milliliters. Now that kind of makes sense. We know that a 2-liter container contains 2,000 milliliters. You should know that. You know that a little can of cool drink is about 330 milliliters. It's smaller. So think if it's the answer's right. If you happen to divide by mistake, then think to yourself, does this make sense? Well, to me it does make sense, because 2 liters, I know how many 2 liters is. I'm going to get more milliliters than just 2. So you can check yourself out with that. Now, next one. 45 milliliters to meters. Oh, examiner's trying to be tricky here. 45 millimeters. Let's check where the millimeters are. There they are. And I want to go all the way to meters. What's the jump? It's a jump of 10, then a jump of 100. So 10 times 100 is 1,000. Skip out centimeters, and I'm going from millimeters, very small, to meters. So what am I going to do? Well, I reckon I'm going to take the 45 millimeters and I'm going to divide by 1,000. Now, be careful here, because so often you write it in the fraction like you've done there, and then we don't write it in the correct decimal format. So be very careful. You're going to write it as 0, comma. Now remember, you've got to make sure that it was like 1,000, so it's going to be 0.045. Check it. Let's do it on the calculator to make absolutely sure. When in doubt, pull out the calculator, it doesn't cost you anything, divide this by 1,000, and you'll see that the answer is the right one, 0,045. The reason I know that is because this is the tenths, this is the hundredths, and this is the thousandths part on the decimal fraction. So if you're dealing with something that's being changed by a thousandth, like millimeter to meter, you know that it must be 3 places away, must be the third one away from the comma. Okay, excellent. Now, this is the one that will probably give us the most headache. But I think we've sorted it because we did some explanation a little earlier, and I hope you've remembered some of that. What we've got is 7,500 centimeters cubed, and we want to convert it to meters cubed. Now remember what we said earlier. We said that 1 meter cubed is the same as 1 million centimeters cubed. Okay? That's what we said. We said if we're going up in centimeters, we get 1 million centimeters cubed is 1 meter cubed. I hope you followed that. Remember, we did 100 by 100 by 100 to get the cubic, and that says 100 times 100 times 100 is 1,000,000. So 1 million is 1 meter cubed. So how are we going to deal with this one? We've been given centimeters cubed, and we want to get to meters cubed. Well, meters cubed is just divide by 1,000 and then divide by 1,000 again. So what we're going to do is we're going to say 750 divided by 1 million. Three zeros and another 3 zeros. Let's do it on the calculator so we get it right. We're going to say 7,500 divided by 1,000. I'm going to do it the short way, the long way. Divide by 1,000 first of all, and that's going to give me that answer because it's 7,5, and then I'm going to divide by 1,000 again to get me my million. And there we go. Now this has given it to me as a scientific notation, which I don't really want. I'm just going to write it down in the fraction way. 0,0075. Hope you can see that. If you aren't familiar with the scientific notation, which isn't part of the curriculum, if you get an answer like that, just think that times 10 to the minus 3 is the third decimal place. Okay, so it must be, the 7 must be in the third decimal place, and then the 5 comes after it. Okay, please revise that. If you're using a scientific calculator and you do get an answer like that, it's sometimes a little bit disturbing. Please don't panic. Try and work it out. One of the ways you can do is if you multiply this by 10 and then you look at the answer, you'll see it gives you with 1 0. Now if we divide by 10, it will give us 2 zeros. So check out, make sure you've got it right. Okay, I think that's helped us consolidate a little bit about converting metric units. Let's go to our next question. So here's one that is definitely not metric, but it can come up. It sometimes has come up in the matric exams. Don't know if it's going to come up in this year's exam, but it's something you need to be familiar with, that there can be different ways of measuring things. And when we're doing cooking, we don't always use grams and milliliters, but we use cups and tablespoons and teaspoons. And so you need to be aware of these and be very clear they've got to give you the information. So in this one, it's just really about converting. 1 cup is 250 milliliters, 1 tablespoon, sometimes written with a capital T, is 15 milliliters, and a teaspoon written with a small t is 5 milliliters. So here's the ingredient for cheese scones. And what we're told is it's 2 cups of flour, 4 tablespoons of cheese, half a teaspoon of baking powder, 2 eggs, 2,5 cups of milk. And now they say to you, how many millimeters of each of the following are used? So let's get to our table. We've got milk first of all. So we know it's 2.5 cups of milk. And we've told that 1 cup is 250 milliliters. So it's 2.5 times what was it? 250. 250. So 2.5 times 250. Let's get the calculator to give us an assistance there. 2,5 times 250. And you get 625. 625 milliliters of milk. That's almost a liter. Remember, you should be familiar with changing that to liters as well. Well, what about the cheese? Let's have a look at the cheese now. They said to us that we needed how much cheese? We need 4 tablespoons of cheese. And 1 tablespoon is 15 milliliters. So 4 tablespoons, capital tablespoon, times 15 milliliters. 4 times 15 should know that that is 60 milliliters. Now that's quite a strange way of putting it on a recipe, because one would think usually you would measure cheese in grams, and that's the normal way. Maybe it's because it's grated and they want you to put it into a cup to measure out the grated cheese. Final one is to look at the salt. We're told it's 0,5 teaspoons of salt. Quite salty, and that is 5 milliliters. So half a teaspoon, which is 5 milliliters, and if we do half of 5, that's going to be 2,5 milliliters. I'm not sure that I'd like to eat these scones, but hope you've got the conversions right. Main thing is to recognize it's a ratio story. Recognize what you've got for one, multiply through, and get them sorted out. Now, let's move on to the next question. Question number 3 deals with imperial measurements. And I think it's quite a fun little question, so let's go and have a look at it. It tells us that George weighs 26 stone, 4 pounds, and 5 ounces. Now, you might be thinking, wow, I've never heard of this sort of story before. Then it also says he's 6 feet and 2 inches tall. Bruce, however, weighs 126 kilograms and is 1,85 meters tall. We're given a whole lot of information, and then they ask us who is heavier. The next part of the question is who is taller. So I think that's a really nice little question. Let's change the imperial measurements into metric measurements and see how we go. So I'm going to start with the weight, also really mass, of George, and we're told first of all 26 stone. So how many, what do we have here? 1 stone is 6,3503 kilograms. So what I'm going to do is I'm going to say I know what 1 stone is. I know 1 stone is 6,3503, and I want to know how many 26 is. So what did I do? I multiplied by 26 to get that. So what am I going to do to that amount? I'm going to multiply by 26, and let's do that on the calculator. Let's take it across here so we can see it. We're going to take 6,3503 multiplied by 26, and we get 165,1078. I'm going to round off to 2 decimal places, 165,12. So in kilograms, 165,12 kilograms. Now, I could stop there, but I'm going to carry on so that you can see how to do the conversion. The reason I said I could stop there is because it asks who's heavier. And Bruce is only 126. And this guy's already tipping the scales at 165, just from the bits of on the conversion of stone. What I'm going to do, though, is I'm going to add up his total mass in kilograms so you can see how to do this calculation. The next part, though, is the 4 pounds. So what does it tell me? 1 pound is 450 grams. I'm going to change that and say, let's make that 0,45 kilograms. So I'm going to say 1 pound is 0,45 kilograms. I want to get to kilograms. I want to change this pounds into kilograms. So I'm going to say 1 pound is 4,5. How many is 4 pounds? Multiply 0,45 kilograms by 4. And that gives me 1,8 kilograms. So I'm going to add in an extra 1,8 kilograms over here. And then the last bit was the ounces, 5 ounces. Well, how much is an ounce? Well, it tells me over here an ounce is only 28,125 grams. So I'm going to take the 28,125 grams because I want to get kilograms. 28,125. I'm going to divide grams by 1,000. Okay, and then I'm going to say that will give me, in decimal form, 0,028125. Okay, that gives me the relationship between 1 ounce and 1 kilogram. But I haven't got 1 ounce, I've got 5 ounces. So what am I going to do to this answer? I'm going to multiply by 5. And that gives me an extra 0,141, or I round it off to 2 decimal places, and it looks fine as far as that's concerned. So now all that I'm left to do is to add up. And I say I've got that number of ounces in kilograms plus 1,8, which was the pounds contribution, plus the stones contribution, which was 165,12. And there we go. His total mass was 16706 kilograms. Now, be very careful. Once you've done that calculation, what you must do is answer the question. The question didn't say find the mass of George. It said who's heavier? Is it George or is it Brian? Or Bruce, sorry. Bruce was 126. George is 167. So clearly, George is heavier because his mass, his total mass, is 167,6 kilograms compared to 126. Quite a big difference in mass. Okay, next one, who is taller? Now we've got to identify the information that we've been given. I'm going to do it in exactly the same way, 6 feet and 2 inches. Let's change from feet to inches. We know that 1 foot is 30,48. So let's do this. 1 foot, 30,48 centimeters, which is equal to 0,3048 meters. So I want to get to the his height in meters. So we were told he was 6 foot. So I want to change 6 foot into meters. How am I going to do it? I've multiplied 1 foot to get 6 by 6. So I'm going to take that and multiply it by 6. Do it, and let's see where we go. So clear that. We're going to say 0,3048 multiplied by 6, and it gives me 1,8288. So I'm going to write that down and say 1,8288. The next part was how many inches was he? He was 6 foot and 2 inches. We know that 1 inch is 25,4 millimeters. 1 inch is 25,4 millimeters, which is 0,25, sorry, not 0, must only divide by 10. So 25, let's just get it right, 25,4 millimeters is equal to 2,54 centimeters. Now, if I divide by 100, then I'm going to get 0,0254 meters. Now, let's take that. He was not just 1 inch, he was 2 inches. So if I multiply on this side by 2 to get that point, I must take that number, multiply it by 2 to get my answer in meters. So I hope you can see that what I've been doing is I've been taking metric units and making sure they're all the same. I did the conversions by taking millimeters to centimeters, and what did I do? I divided by 10. And then I took centimeters to meters, and I divided by 100. And now I'm going to multiply the meters by 2 to get me my inches, because the inches were 2 inches, and that's where we're going. So let's pull up that calculator. I'm going to come back to that value, but I'm going to just clear it for the moment. 0,0254 times 2 equals 0,0508. 0,0508, and that's in meters. So what have I got to do to get the total height? George's height. George's height is equal to, let's find it. There it is, 1,8288 plus 0,0508. Let's add it in, and let's see where we go. 1.8288 equals, and there we've got, you know what, I didn't do the right addition. Let's do it again. 1, make sure you get your commas in the right place. 1,8288 plus 0,0508 equals 1,8796 meters. 1,8796 meters. Now, what were we told about the other guy? Bruce, what were we told? He was 1,85 meters tall. This guy is 1,8796 meters. Now, we could round that off to 2 decimal places and say 1,88 meters. And so George is taller. He's also taller. He's taller than Bruce. Okay, so he's not only heavier, but he's also taller. Makes an interesting question. Now, I think that we've done a substantial number of conversions. Let's move on to another interesting one. We're looking at conversion of temperature. Again, a sort of non-metric sort of calculation, but this one is quite straightforward. We're told that the temperature in Washington, in the United States, probably the USA, is reported to be 30 degrees Fahrenheit. We're told to convert this into degrees Celsius and then say if it's hot or cold. So they've even given us the formula, and we want to just be able to work that out. So the first thing we're going to do is we're going to say temperature in degrees Celsius is equal to the original temperature, which was 30 degrees Fahrenheit. We're going to minus 32, okay? And then we're going to take that and we're going to divide it by 1,8. So if I do that, think you can predict already that it's going to be quite a small number, or even a negative number. Minus 32 is negative 2 divided by 1,8, and we get the answer of minus 1,1 degrees Celsius is equal to negative 1,1 degrees Celsius. Excellent. We finished the question. No. Remember what it said. Say if it's hot or cold. It's very cold. It's cold. Okay. It's below freezing point of water. It's probably snowing. There's probably ice outside. The water will have frozen in the dog's bowl. It is cold. You're going to have to wear a jacket and a coat and a jersey and a hat and make sure you stay warm. And you're probably going to need a raincoat on top of all of that, because Washington weather can be very miserable. Okay, now talking about going overseas, here's another interesting little question about traveling. We're dealing with time here. Now, traveling comes up, and you need to be able to allocate and be able to read off tables, timetables, and all that sort of thing. Here's one that tells us that a plane took off from OR Tambo International in Johannesburg at 11:30 a.m. and it was flying to London. The time in London is 9:30 a.m. on the day of the departure. The flight takes 11 hours and 7 minutes. During the flight, Peter sits back. He's trying to take up some time, and they've put on a movie. He starts watching the movie at 2:25 and the movie ends at 16:41. First question is, how long is the movie? The second, we're asked about the plane lands on time, so it did actually take that amount of time. What time is it in South Africa, and what time is it in London? Now, this sort of question you've got to break down bit by bit. Let's make sure that you read the whole question, and then we go back and work out what information we need to answer each individual part. So the first thing that I'm going to do is I'm going to say the movie started at 2:25 p.m. I don't like it in that format. I don't want the formats to be different. So I'm going to change 2:25 p.m. to the 24-hour clock format, which is saying 14:25. And that's when the start was. And now I'm going to put in the end as 16:41. Now, guys, I hope you can see that you can almost do this in your head, because you can say to yourself, well, I know that to go from 14 to 16, that's 2 hours. So I know that the movie is 2 hours to a certain point. Now the difference is I've got 41 and 25. It would have been, let's count it, we start at 2:25, 3:25, 4:25. That's my 2 hours. So now I'm going from 25 to 41. And I'm just going to use my calculator to do that, because why not? I'm going to say, there we go, clear it, 41 minus 25, don't want to make a mistake, and there I get it, it's 16 minutes. Yeah, I could have used my fingers to count that up, but it's so much easier to use the calculator. 16 minutes. And there I've got it. Converted the units so that they're easy to work with, and then work them out from there. Please be very careful, though, that you don't work with minutes and time separately. If you're going to want to calculate them all at once, you must make sure that you convert the minutes to hours, decimal hours. Okay? So don't just be, this would be a mistake to say 14.25. That's not the same thing. It's not 14 hours and 0.25 of an hour. It's not. It's 25 minutes out of the hour. Just to remind you, 25 minutes out of the hour divided by 60 is actually going to be 0.41 parts of the hour. So you could do it that way. There are lots of ways to do these calculations. I just have chosen my way. Keep the hours and the minutes separate, or do a conversion between minutes and hours. Now, next thing, we're asked about the time when the plane lands. Now, we're told it takes 11 hours and 7 minutes. And we started at 11 a.m. in the morning. So all we've got to do is we've got to say, this is South African time. Took off from OR Tambo in SA, and that was the South African time. We're going to add 11 hours to 11:30. And that means that we're going to get 22, and it was 30, and it took 37 minutes. So it's 22:37. If they wanted us to write it in the same format that they did, that would be 2200 is going to be 10:37 p.m. Okay, so be very clear about how you add those two together. There's an hour before noon, and there's 10 hours after noon gives you your 10 o'clock in the evening, 10:37 as the difference. Now, if they asked us, what's the time in London? Now, that was the next part of the question. There are different ways of doing it. What we could do is we could add the flight time to the given time that it was in London at the start of the flight. Or we could do the following. We could say, hold on, what we notice is that 11 a.m. and 9 a.m., what's the difference in time? The difference is 2 hours. It's a 2-hour difference in time. And London was 2 hours earlier. Notice this is earlier. Okay? So that means that I can take 2 hours off this time and say in London it's going to be 8:37 p.m. or 20:37. Notice that when I write it as a 24-hour clock measurement of time, I don't put AM or PM. It's just the two digits for the hours and the 2 digits for the minutes and the colon in between them. When I'm writing AM or PM, then there's only 1 digit for the hour. Sometimes, like if it's 8 a.m. in the morning, then it's 8, 2 colon 00 a.m. But for 24-hour clock, we don't use AM and PM. It's unnecessary to put those units in as well. Okay, I think it's time to look at our last question. It's quite a nice one, so let's get going. It tells us that Lindsay is visiting her sister in the United States, and she needs to drive a distance of 420 kilometers to get to her sister. She drives at an average speed of 75 miles an hour. So that's different. Lindsay started the trip at 1:17 p.m. So that's just after lunchtime. We are given that 1 mile is 1,609 kilometers. First thing is, how fast is Lindsay driving in kilometers per hour? And the last question is, will Lindsay reach her destination by 4:40 p.m.? Now guys, we've got to take this slowly and step by step because we're interested in doing some conversions here. And the conversion that we're looking at is we've been given miles to kilograms, but we've been given a speed as 75 miles per hour. So a speed, distance, time conversion is sometimes a little tricky, and you've got to keep your wits about yourself. So let's make sure that we've got it all sorted out. It's not as difficult as it might seem, but we will get going with it. So the first thing I'm going to do is I'm going to write part A and just work down below. We're told that we've got 70 miles per hour. What we really need is we want to know how many kilometers that is per hour. So in 1 hour, we know that she does 75 miles. How many kilometers is that? Well, we were also told that 1 mile is equal to 1,6, and then it was 0.9 kilometers. And if you think about what we've been given, it's 75 miles here. We want to work out how many kilometers there are. So what did we do to this side? We multiplied by 75. What am I going to do to that side? I'm going to multiply by 75. So if I do that, pull up the calculator, I'm going to say 1,609 multiplied by 75, and that gives me the number of kilometers per hour I was traveling. And it's 120,675 kilometers. Now, 75 miles is 120,67, so the kilometers per hour, 120,675 kilometers per hour. Now, remember, this is the average speed. So Lindsay was going a little bit quick. She wasn't just taking her time. She could have gone a little bit quicker, but on average, even if she stopped for a break, that average speed over time means that she was really going as quickly as she could to be safe. Now, the next part tells us that she has to travel 420 kilometers. And we want to know is, will she reach her destination by that time, by 4:40 p.m.? So what I'm going to do for part B is I'm going to say to myself, well, she's got to travel 420 kilometers. The distance she has to travel is 420 kilometers. Her speed, her average speed is 120,675 kilometers per hour. And I want to know the time. So what's the relationship between speed, distance, and time? Well, you should remember that speed is equal to distance divided by time. And you can see it here in the units. It's kilometers divided by hours. Kilometers is the distance, hours is the time. We want time. Now, if I'm going to do this sort of calculation, I don't know time at the moment. What I'm going to do is I'm going to substitute into that little equation first of all, and then work out what time is. Time isn't known, so I'm going to put down my speed, and I'm going to say 120,675 is equal to my distance, which was 420, and my time, I don't know. So how am I going to get time by itself? Well, I'm going to multiply both sides by time. I'm going to say time times 120,675 is equal to 420. And then I'm going to divide by 120 both sides. And I'm going to go 420 divided by 120,675. Let's put that into the calculator, and we can check that it is actually right as well in a minute. So let's make doubly sure. We're going to take 420 kilometers divided by the speed of 120,675 equals, and that gives me, very important to realize, 3,48 hours. But guys, this is hours as a decimal. The 0.48 is not really minutes. Okay? Let's just check that we've got it right. And the way to check that we've got it right is to go back to this formula, okay, which said distance divided by time will give me speed. So I always like to do a little check and see to myself. 420 I know, and I wrote down what the hours was, 3,48, 3,48. Let's see if that gives me my right time. So remember, with rounding off, we need to just be very clear. Might not be exactly the right number, but it will be very close if it's right. 48, what is it? 120,689. Now look, 120,75. I think it's close enough. 120, and so I'm going to tick that I've got the right amount of time because I rounded off to 2 decimal places. So I'm fine with that, but I'm not finished the problem yet, because I must remember that this 3,48 is 3 hours and 0,48 of an hour. I want to change it to minutes. So I know it's 3 hours, but I want to get to minutes. So I'm going to say 0,48 of an hour is how many minutes? That's a fraction of an hour. I'm going to multiply it by 60 to get the number of actual minutes. So let's do that. Say 0,48 of an hour, which was 60 minutes, gives me 28,8 minutes. Now I'm going to round that off. I'm going to say 29 minutes because it's close enough. We could have gone the 0,8 and checked how many seconds that was. We'd take 0,8 times 60 to give us the seconds. I'm not going to worry with that. I'm just going to say this is 28 minutes. It's almost 29 minutes, 28,8 minutes, which I'm going to round off to 29 minutes. We'll know that if she's a minute out, that she might not quite make her time, but I think 29 minutes gives us a good enough estimation. So she's going to take 3 hours and 29 minutes. What was her starting time? Because this is what we had to work out. She left at 1:17. So she left at 13:17. We're going to add 3 hours to that. 13 plus 3 gives us 16. Now, 17 plus 29. 17 plus 29 equals 46. So she's only going to get there at 16:46. What were we asked? Is she going to get there at 4:40 p.m.? Now 4:40 p.m. is 16:40. And what have we got to answer? We've got to answer that question. We've got to say, no, Lindsay will be 6 minutes late. And it's about 6 minutes because we know that 0,8 of a minute is close enough to, she'll be about 6 minutes late. Okay? So she's not going to get there on time. Talking about time, we've come to the end of today's lesson. We've run out a bit of time. Hope you've enjoyed this session on measurement. Do join me again for another Learn Extra lesson on mathematical literacy another time. Bye from me. Hello grade 12s, welcome to Learn Extra. Today we are dealing with mathematical literacy. The topic we're going to cover is the topic of measurement. Now measurement is really interesting because if we think about it, we need measurement for things to be fair. You don't want to go into the shop and say, I'll have a kilogram of flour And the next day you go in and you say, I want a kilogram of flour, and the baker or the grocer gives you a different measure. You want to have a standard way of measuring. And in the same way, we measure things all the time. We measure the length of things, we measure the weight of things, or the mass of things. We measure time, we measure temperature, we measure all sorts of different things. And that's why the study of measurement is actually a science all on its own. But for our purposes, we're just going to deal with the very basics of measurement. So let's get going and see exactly what we're going to do today. We're going to, in this session, revise two very important systems. The first one is converting in the metric system. So we're going to talk about the metric system and how you do conversions of metric units. So when we're in the metric system, how do we convert one unit to another? Some things are very small, so we can't use a universal way of measuring things. We have to change the system of measurement depending on how big or small something is. Then we're going to look at conversions between metric units and non-metric units. Now, there are a number of non-metric units. We're going to be looking at some non-metric units that are commonly used, as well as looking at the imperial measurement units. And so in different parts of the world, not everyone has converted to metric. I don't know why, because metric is so much easier, but for traditional reasons, in some parts of Europe and some parts of the United States, they use the imperial measures. And even then, you're going to divide. Going the other way, you're going to multiply. And that's all quite straightforward. Now, guys, what you need to recognize is that volume doesn't always get measured in liters or milliliters or kiloliters. We can also use a distance measurement to measure volume. And this is where it might become a little bit tricky. Because what we do is we can say, if we've got an object that is a square or a cube, then that has a certain volume to it. And you would agree that the volume, from what you've done previously, volume of something like this, they call that height and call that breadth. The volume is length times breadth times height. And so what would we say? If this was 1 centimeter, and that was 1 centimeter, and that was 1 centimeter, then we would get 1 centimeter times 1 centimeter times 1 centimeter. And that would give us something called 1 centimeter times centimeter times centimeter times centimeter. That's called a cube. Centimeter times centimeter times centimeter, cubic centimeters. And the interesting thing now is that 1 centimeter cubed is the same as 1 milliliter. Okay? So 1 centimeter cubed is the same as 1 milliliter. Very important for you to get to that. Now, if we had something that was 10 centimeters by 10 centimeters, so it's 10 centimeters by 10 centimeters by 10 centimeters. Notice 10 times 10 times 10, that's 1,000 centimeters cubed. And 1,000 centimeters cubed is exactly the same as 1 liter. And then we could even go to something that is 100. Then they adjust things to suit themselves, and it becomes a huge discussion. In science, we have standardized those measurements to a large extent, but in common usage, most people still use what they've traditionally used. We're also going to look at some time calculations. Now, these can be extremely interesting and sometimes quite fascinating. And you kind of think, well, what exactly is going on here? But we'll get into that a little later. Let's start off with some explanation. So we're going to start off looking at the metric system. Metric basically comes from a French system where, because we count and we have our number system in units of 10, that's the decimal system. And everybody likes to multiply by 10. The metric system is generally and loosely based on powers of 10. So it's actually 1,000 or 100. So you can convert from one thing, either from 10, going up in units of 10. Let's just write it clearly. 10 or 100 or 1,000. And so we can step up in those sort of measurements. Each one of these smaller units has in fact got a name to it, and you should be familiar with it. So let's have a look at length and distance. If we're measuring length or distance, we could start with something that is in millimeters. So millimeters written as mm, and if we had 10 millimeters, we would get to the next unit. So the jump up to the next unit is to centimeters, and that is a jump of 10. It's a step of 10. We need 10 millimeters to get 1 centimeter. And then the next jump, so the jump there is a size of 10. The next jump to get from centimeters to meters is 100. Centi is like century. Century, from both the turn of the century and scoring a century in cricket, is 100. You should be aware of that. Century is not an unfamiliar word. So if we're going up to meters, the next step we'd get to is kilometers. And that step is 1,000. Now, I hope you can see that that's quite an easy way of going up in those steps. 10, then 100, then 1,000. So if you asked about conversions, my hint to you is you write this down on your exam paper or on the question paper, so you've got it very clearly. The important thing now that we've got to decide is if we're going from a small unit like millimeters to centimeters. So we're going from left to right on this table. What do we do? Do we divide or multiply? Well, you think about it. If I have 10 millimeters, that's 1 centimeter. So going from left to right, I'm actually going to divide. So if I'm going up the table, I'm going to divide. Centimeters to meters, I divide. So in that direction, going from small to big, I always divide. But if I'm going in the opposite direction, from kilometers to meters, I multiply. From meters to centimeters, I multiply. From centimeters to millimeters, I multiply. So from a very big unit, and you can think about it, a meter is about the length of your arm, a centimeter is about the length of your fingertip. The top of your thumb, and a millimeter is even smaller. It's as close as you can get to looking at it, and you've got your ruler. You look at your ruler and you'll see which one is the big one, which one's the small one. Recognize that when we're going from small to big, we divide. Going from a unit that is big to a smaller unit, we multiply. Okay, I hope you've got that very clearly and you understand about the change when we're dealing with length and distance. Now, what about mass? Well, good news, we have a very similar system. Instead of changing all the things, we've got milligrams, and then we have grams, and then we have kilograms. Now, the prefixes, these things in front, are the same in distance and in mass, and in fact in other units. If we chose to measure some other things, you would find they're the same. So you could get some things like milliseconds or kiloseconds. We don't often get those in everyday conversation, but it's possible that we could. Milli means 1,000th. Kilo means 1,000. So the difference between milligrams and grams, I want you to see the jump here in mass is not going up in 10 and 100, but it's 10 times 10, which is 1,000. And that makes it really interesting and makes it very consistent. From grams to kilograms, it's 1,000. So it's all based on that system of metric, units of 10. Now you'll see later that other units don't follow that rule. They don't follow a standard setup. Just to remind you again, if we were going from the small unit to the big unit, then we would divide. So milligrams to grams, you divide. Grams to kilograms, you divide. But if we were going from kilograms to grams, we'd multiply. That makes sense. 2 kilograms, 2,000 grams. 2 kilograms, it sounds small, but it's actually quite heavy. You know what 2 kilograms feels like? It's 2,000 grams. Grams is a smaller unit, so there are more of them. And if we were to go to milligrams, we'd multiply again by 1,000. Okay. Now, the next thing is volume. Now, there were 2 ways of measuring volume. It depends on what you're measuring. Usually if we're measuring liquids and we're measuring things that can pour and have capacity, that fill an object, that sort of measurement, we use the following system. We say we've got milliliters, and we've got liters, and we've got kiloliters. Now, see, it's very similar to the mass story. And again, you have got it right if you said, well, the difference, the jumps between these is 1,000. And the jump between that is 1,000. Absolutely right. And we'd follow the same rule. From the small unit to the big unit,